Okay. So you said the answer is C, right?
Yes.
But the answer is not actually C. Let me tell you why. If you go by your C, C is the answer. This means by number of proton is 9. That is for this C now.
Okay.
Also means that my number of electron here is 8 for option C.
Okay.
And my number of neutron will be 17 minus 9, which will give me 8. So those information, does it tally with the information we have?
No.
So the answer is B.
B.
Yes.
I thought 16. I thought it was from what you just explained.
Okay. Now let's break it down. For what I just explained, number of proton for B is 8.
Yes.
Number of electron for this B will be 7.
7 plus 8.
Number of proton, 8. Get that one first. Number of neutron.
Yes.
Number of neutron, 8 minus 17. That should give me what? 17 minus
17, that's 9. That's 9.
9 for neutron. Then electron will be 8 minus 1, which is 7.
Okay.
So,
All right.
yeah, so that is it. Any other,
Okay.
are you very clear with it now?
It's okay. Yes, I will still look at it again on my own.
Okay, no problem. It's allowed. So we are moving on to next thing now. Isotopy and isotopes. Isotopy and isotopes. So let me write something maybe to trace this story. Okay. Which symbol of element is this?
Chlorine.
Chlorine. Okay. This 17 here is my what again?
17 is atomic number.
Atomic number. This 35 is
Mass, atomic mass.
atomic mass or mass number. Okay, the same thing here too. 17 atomic number, mass number 37. Let's calculate the number of proton here. Also the number of neutron. What is our number of neutron?
Our number of neutron is
The first one.
35 minus 17.
Yes, that gives us.
That gives us 18, right?
Okay, 18. 17 plus 17 is 34. Okay, 18.
34, that's 18.
Then here, number of neutron.
Neutron for that one should be 20.
Perfect. Now, looking at both of them, they are atoms of which element? Both of them are atoms of which element?
Chlorine.
Chlorine. Okay. Both of them have what in common? And what is the similarity between both of them?
Their atomic numbers, they are the same.
Okay. What is the difference between both of them?
They are neutron.
And what else?
And their mass number.
Okay. So this thing now is called isotopy.
Okay.
So by definition, isotopy is a phenomenon. Isotopy is a phenomenon whereby atoms of the same element. Isotopy is a phenomenon whereby atoms of the same element have the same atomic number but different atomic mass. due to their difference in their number of neutrons.
The same atomic number,
but different atomic mass due to their difference in the number of neutrons. Is that okay?
yes.
Okay. Sometimes they used to ask students to define isotopy and isotopes. If you are defining isotopy, the key word there is the phenomenon. That word must be there.
Okay.
Then,
Okay.
when defining isotopes, you remove that I phenomenon. It's no longer phenomenon now. Isotopes are atoms of the same element. That is the definition I'm giving you now. Isotopes
Okay.
are atoms of the same element, which have the same atomic number, but different mass number due to the difference in the number of neutrons.
The same elements, the same atomic number, but different atomic mass.
Yes, due to their
Due
difference.
to the difference in neutron. Okay.
Is that okay?
Yes.
Now you can write examples of elements that exhibit isotopy, because they used to ask this question in theory. Maybe give 3 examples of elements that exhibit isotopy. Hydrogen, chlorine, oxygen, hydrogen, chlorine,
and oxygen.
etc. I'll put other examples there, but those are common ones. Is that taken?
Yes.
Okay. Any question?
No.
Okay, let me look for one theory question as regards this, the way I put it. I'll see any theory question like that under this aspect. Okay, in the while I said this, you can write a subheading there, calculating mass number from isotopy. Calculating mass number from isotopy. Have you written it?
Yes.
Okay. So let's see. I have a lot of them. But funny enough, when you are looking for it, you will not see it. You promise you are going to get to get one before school resumes.
I will.
And this one I'm my own. Some pages out because it has been overused. Okay, so let's write example 1. Are you ready?
Yes.
Sorry, just a minute again. Okay. If 100 atoms of element X. Are you there?
Yes.
If 100 atoms of element S contains 70 atoms of like this, S8 like this, 70 atoms of X with mass number of 8. Are you there?
Yes.
And 30 atoms of X11. So this one is 70 atoms, and this one is 30 atoms. Good stuff. Calculate the relative atomic mass of X. Calculate the relative atomic mass of X.
Of
X.
X.
Huh?
Yes.
Okay, so now the first line says that there are how many atoms?
The atoms.
Yes, the
There
first
are 2.
The first line said what? If
100 atoms.
good. So inside that 100 atoms, now 70 atom is this. 30 atoms in this one. Are you with me?
Yes.
So that means this, to get relative atomic mass, I'll say relative atomic mass is equals to 70 over 100.
Okay.
Hope you understand where I got this 70 over 100 from.
70 over 100 is not the
This,
total.
this 100,
This 100 is from me.
the total atom.
Okay, yes.
That is in terms of percentage now. Times 8 over 1. That is the mass number of this one. Plus, open bracket again, 30 over 100 times 11 over 1. So this is what you just do and you get your answer.
Okay.
If you have a calculator there, I don't have one, you can use your phone and do this. Because this can cancel out, this cancel out. It should be 33 divided by 10, that should be 3.3. I can do that one quickly. Then 7 times 8. 8 times 8 is 64. So 7 times 8. 8 times 8 is 64. That means 8 times 7 will be 56. Divide, that will be 5.6. Add it, that should be 8.9. So that is the relative
Atomic
mass. If you have a calculator, you can do it also, do and confirm it. But that should be.
I'll confirm it later.
You confirm it later. Okay, now. Are you ready?
Yes.
But I'm trying to check something here. The options that are here is 9.6, 10.6, 11.6, 20.0. So that is why I need you. Okay, so I know where the mistake is coming from. This is, did I say 8 in the question or 9? The question was 9. Sorry, this is 9, not 8. That's
okay.
the option. So this is 9. So let's correct this now. 7 times 9. If 7 times 8 is 64. 7 times 8 times 9 rather. Or 7 now, yes. 9 times 7.
7 times 9.
Or 7 times 7. Or 7 times 10 is 70.
So that means we have 60.
63. So this will be 6.3. That will now give me 9.6. So the answer is 9.6. Any question?
Okay. No, it's okay.
Okay. It's okay. I like that. Okay, let's look at another one. Example 2. Are you ready?
Yes.
Okay. The relative atomic mass of a naturally occurring lithium. The relative atomic mass of a naturally occurring lithium consisting of, I'll write it like this, 90%.
Consist what?
Consisting.
Consisting of
90% on the board. 90% 7
okay.
Li and 10% 6 3 Li is dash. We're asked to calculate the relative atomic mass. Sorry, let me do this work. Did you get it?
Relative atomic mass.
We have to calculate the relative atomic mass.
That's what I'm doing.
Okay, okay.
70, 90 over 100 times 7 over 1 plus 10 over 100 times 6 over 1. So this is I need calculator. I can't use my phone right now.
Yeah.
But you say?
I said, okay then. But there's a but. What's the but?
Let me try and use my phone. I'm coming.
But anyway, I'm sure you're on the right path.
Let me just quickly see what I can do. This phone is doing somehow.
But
Okay.
let me just run through what you did and I'll know whether you are on the right track. We'll continue. What you did was 90 over 100 times 7 over 1, right?
Yes.
Plus 10 over 100 times 6 over 1.
Yes.
Okay. If you follow that part rightly, you get 6.9 as your answer.
I'm coming. Yes, it's 6.9.
Okay. So that is that. Let's go to example 3. We have 5 examples. We do 3 now.
Example 3.
Yes. It's on the board. If you can see it.
I'm not saying it, please say it out.
Okay. So
Chlorine consists of two isotopes.
consists of two isotopes of mass. Two isotopes of mass numbers 35 and 37. In the ratio of 3 to 1. That again?
The ratio of 3 to 1.
Calculate the relative atomic mass of chlorine. Calculate the relative atomic mass of the chlorine. Is that taken?
Yes.
So can I clean the board?
Yes.
Okay. So if I give you such a see now, this question is different from the first two that we did, right?
Yes.
So what is the difference?
This one is given in ratio.
Very good. The first two were in percentage. So expose your students to the questions like this. And it's not every time it should be given in percentage. It can be given in ratio. So when given in ratio, you are going to do it like this. Chlorine, and use the symbol Cl, Cl. One is 35 mass, and the other one is 37, right? Or was it 37 that came first? Let's get it right. Which of them was written first? Huh?
35 came first.
Okay, 35 came first. Then the ratio is 3 to 1.
Yes.
So what we now do is say sum of ratio. Sum of ratio will give me 3 plus 1, which will give me 4. Then the relative atomic mass will be the ratio of this, which is 3, over the sum of ratio 4 times 35 over 1.
Okay, of the first one.
Of the first one. Then the ratio of the second one, which is 1, over the sum of ratio 4 times the relative molecular the molar mass 37 over 1.
37.
So this is what you do. Because you also don't have a calculator there, If you go ahead and solve this, you should get 35.5.
Okay.
Any question?
No, it's clear.
It's very clear. Crystal clear like water. So another thing now is sometimes it can be given the relative atomic mass and given the abundance of one and asked to find the relative molar mass of the other one, like a question like this. So let's look at this particular question. Are you ready?
Yes.
Okay. I'll look for it. Okay. Where does it go? Let me look for that particular one. Okay, an element X. An element X with relative atomic mass 16.2. An element S with relative atomic mass 16.2. Are you there?
Yes.
Contains two isotopes. Contains two isotopes. I write it like this is the first one. X, this, with relative abundance of 90%. And XM8 with relative abundance of 10%. Find the value of M. Is that taking?
Yes.
Okay. So how do we go about this? Can I clean the board?
Yes.
Okay. So I'm going to clean the board and write some information the way I like it to be done. The first one is X. What is the atomic number of that first one?
The atomic number is
Our mass number is 16, right?
16, yes.
Abundance of this one is 90%. And the second one is X, 8, and abundance 10%. And we're given that the relative atomic mass is 16.2, right?
Yes.
Okay, so now we're asked to find the value of M. Now this is what I'm going to do here. All right, 16.2 equals to 90 over 100 times 16 over 1 plus 10 over 100 times M over 1. You get that?
Plus 10 over 100 times what is that thing?
M over 1, that is this M here.
Okay.
Then I think 0 can cancel 0. At this point, I need your calculator now. 0 can cancel 0. 0 can also cancel 0. So 16.2 equals to 9 times 16. 9 times 16.
Please hold on.
Okay.
9 and 6 is 144.
9 times 16, not 6. 1 6. 9 times 16.
16.
Yes.
144.
That is 144.
Yes.
Over 10. I don't need to use the, you can leave it like that. Then 1 times n is m over 10. You understand this?
Yes.
We'll find the LCM of this side. LCM will give me 10.
10.
10 cancel 10, 144. 10 cancel 10, m still equals to 16.2 over 1. Are you with me?
Come on.
If you don't get it, let me know.
Okay, 16.2 comes in now.
Yes, the 16.2 over 1 will come in back.
Over 1, yes.
Then at this point, I will now do what we call cross multiply. This multiplies this multiplies this. So
Okay, let me calculate.
if 16.2 multiply 10, that will give me 162. Please, well, you can use your calculator to do that. Then 1 times everything here still remains the same thing. 144 plus n.
Yes.
Then I will collect like terms. If I collect like terms, m will be 162 minus 144. So what do we have? If you subtract 144 from 162.
162 minus 144, you have 8, and then you have 1.
So your
The
answer
answer is 18.
So value for n is 18.
Okay.
So that's the answer there. I think I've done justice to it. I can. How many examples have we done? I did say 5. So let me know if I've done up to 5.
I think it's 4.
Okay.
Example 1, example 2, example 4.
Example 4. That we have done 4 examples.
Yes.
Okay. One more. Then let me look for that one. Are you still writing? Or you are ready?
I'm ready.
Okay. Chlorine consisting of 2 isotopic masses. Chlorine consisting of 2 isotopic masses of chlorine consists of 2 isotopic masses, or 2 isotopes rather. Chlorine consists of 2 isotopes of mass number 35 and 37. Mass number 35 and 37.
Please hold on. Hello.
Yes, let me come again, right?
Please hold on. Let me go and pack clothes. It's raining.
Okay. Oh yeah, go ahead now.
You are so good to me. For all you are, excellent in my life. Back.
Okay.
consisting of
Please on the board.
two isotopes of mass 35 and 37.
Has an atomic mass of 35.5. Has an atomic mass of 35.5. The relative abundance of isotope of mass number 37 is
what?
Is question mark.
Okay, that's it. Okay.
That's the particular one you're looking for. We have just less than 8 minutes to go, so I'm going to be very, very fast to finish this up. It will not be nice to come back again just because of this small thing. So let's finish it quickly. Are you ready? Let me clean the board.
Okay.
Can I clean?
Ready.
Okay.
Yes.
So quickly, the element is chlorine. I can also see right there, chlorine. Mass number of, what is the first one? Is it 37K first or 35K first?
35.
Okay,
35 is the first one.
37. Were we given the relative abundance?
Relative abundance is 37.
No, we're not given relative abundance.
The relative abundance of isotope of mass. Okay.
So we are looking for relative. So now say let the relative abundance be X. Are you with me?
Yes.
Okay. We're also given the relative atomic mass to be what?
$35.5.
Okay, 35.5. So I'm now coming out right now. The first one, 35.5 equals to, remember the relative abundance is what? S, right?
X, yes.
That'll be X over 100, because it's always percentage, times 35 over 1. Is that taken?
Yes.
Plus, now remember, if the relative abundance is X, let's assume this one was, maybe the relative abundance of this is 70%. What would be that of this one? If assuming 35 was 70%, 37
30.
30. How did you get the 30? You subtracted 70 from 100, right?
Yes.
I'll come here and say 100 minus X over 37. Sorry. Over what? Over 100 rather.
Over 100.
Times 37 over 1. Any question?
No.
Okay, so we'll solve them separately. 35 times X, I'm fast because of time. 35X. Any question?
No.
Over 100 plus, now I'm going to use this to open this. Are you with me?
Yes.
So 37 times 100 will give me 3,700 minus 37X all over 100. Taking?
Yes.
Okay. Then I want to clean this first, this top part. So if you're writing, you can quickly just write, so we'll clean it up. Can I clean?
Yes.
Okay. LCM here will give me 100. 100. 100 into 100, 1. 1 times 35, 35X plus 100 into 101. I repeat the same thing. 37,000 minus 37X. All equals to 35.5 over 1. Is that okay?
Okay.
So now, at this point, I will cross multiply. 35.5 times 100 will give me what? 3550. If you multiply that, And then 35x plus 37,000 minus 37x. Any question?
No.
Okay. We'll collect items here, or rearranging it, essentially are saying 3550 equals to 3700 minus 37x plus 35x. I just rearrange it. The same thing as this.
3550 minus.
No, 3550 equals to this equals to here. Yes, the equals to is still there. Then this part, I rearrange this part, bringing this 37 forward, taking this one, just rearranging it, I'll still get the same thing.
Okay.
Then minus 37x plus 35 will give me minus 2x. So this will give me 37,000 or 3,100 rather, minus 2x equals to 3550. Then we can collect like terms.
Okay.
So if you collect like terms, taking these two becomes loss. So
2x
3700 minus
550.
So 2x equals to, subtract that.
That's 250.
Is it 250?
Yes.
No, I'm not sure. Can't
It's
give me
250.
Do it again. 3,700 minus 3,550.
0.
That should be 150.
150, yes, 150.
150. Then divide both sides by 2. So x is equals to 75. Are you with me?
Yes.
Okay. Remember, they asked us to calculate the relative abundance of which of them? Quickly. It's at the end, I'll finish it.
Of the relative abundance of isotope of mass number 37.
37. Can you go back to the beginning where we started from?
Yes.
Okay. Which of them came first? Was it 35 or 37?
35.
We have 35x, or sorry, let me use yes, x, and we have 37, chlorine rather, right?
Chlorine.
Chlorine. And we said let the relative abundance be what? 75, right?
Be 75, yes.
When I was doing this, we said 100 minus 100 minus s. You know what I wrote there?
Yes.
So now to get this 37 now, that will now be 100. Now since our s is 75, that becomes 100 minus 75, which is 25. So the relative abundance for this one is 25. That's the answer.
Okay. X equals to 75. That's equals to.
No, you now say since the relative abundance was x, you now become 100 minus 75, which is 25. That's
Okay.
the one.
Okay.
So what we calculated for was to get x. So that means the first one of 35 is the one that has the 75. While that of 37 is 25.
All right.
Thank you very much. It's about to shut down now.
Thank you so much. Thank you.
So I will still put the video on my channel. So, but then you can